ellipses. Let's see what you remember about an ellipse. So if we draw an ellipse, we learned yesterday there are two L's in ellipse. Yeah, it's true. And we learned that there is a center, H comma K, and there are two focal points. This focal point, this focal point. Do you remember what I proved that formula to be? If HK is in the origin, what will this be? I don't know if you memorized that, but let me tell you what it was. AE comma 0. Negative AE comma 0. That's the focal point. A is the major axis, and B is the minor axis, which we're going to get to in a minute. All right, and then we have the directrix. X is to A over E. And this one will be X is equal to negative A over E. None of that means anything until we find out what A and B are. So here's your formula. X squared plus Y squared equals R squared. What formula is that? Circle. We don't have a circle. We have a 1 here, and instead of R squared, we have A squared, B squared. Okay? Now, A, I'm going to highlight here. A is this distance to here. That's what A is. B is this distance up to here. So we have a name for this. We call this the major axis. How far is that, by the way? How far is it from here to here? That's 2A, isn't it? Yeah. And 2A is kind of going to be interesting. We'll come back to 2A. This is the vertex, and this is the vertex. Yep. And then this distance up here is going to be, this point is 0B. This is 0, negative B. You could call this A0 and negative A0 for the vertices. So those are the vertices. All that work I did yesterday was to get this formula. B squared equals A squared times 1 minus E squared. That, I think I just snuck in before the end of the hour. Is that correct? And this is how we calculate B from, well, we can go back and forth and do different things. There's only one other thing I wanted to mention. Did you have a question? One other thing I wanted to mention is that if we are looking at here to point P and here to point N, which is A over E comma Y, what is the ratio of P N? I always do this backwards. Everything looks great except I shouldn't have this line here. There we go. This to the focal point. Focal point, like that. This is F. PF over PN, what is that equal to? E. Okay? Now, for an ellipse, which is larger, P of N or P of F? Which is larger? Yeah, this is the big one. Okay? So, if P of N is always greater than P of F, E must be what? Less than 1. Would you write that down somewhere? That is the key to understanding ellipses, because for the parabola, E was equal to 1. We love that. P of N equals PF. But for this one, it's less than. this is going to impact your understanding of formulas. Think of it this way. If E is less than 1, tell me if E is less than 1, what's this quantity in here going to be? Less than 1, right? So what can you tell me about B squared? If this is less than 1, which it is, this is less than 1, then what does B have to be compared to A? Has to be less than, yeah. And so for this setup up here, B less than 1, that works because the E is second, 1 minus E squared. Take a look at this, A over E. If E is less than 1, is A over like a half going to be bigger than 1? Yeah, because it has to be out here. How about this focal point? If E is less than 1, is this point going to be less than this A? It only works. So I think that was the most helpful thing for me, is to think that E is less than 1, all of this is going to work. And then the other formula is everything's the same, but if you turn it, we switch A and B so that all these other formulas work. Well, let's take a look at just this first one. Hopefully it'll make a little sense. Divide everything by 36, right? So you're going to get x squared over 9 plus y squared over 4 equals 1. Now, for the formula x squared over a squared plus y squared over b squared equals 1, what's a equal to? 3. Yep. And what's b equal to? Good. 2. So when I'm drawing a picture, we could draw this just from this information. It's going to go up to 2, down to -2, over to 3, back to -3, and it'll make that nice little ellipse. That's all that you really need for drawing it. But we're going to find E and the directrix and the focus. We're going to do all of that. Okay, let's find the directrix. No, let's find E first. B squared equals a squared 1 minus e squared. And I think I mentioned this already. For an ellipse, E has to be greater than or less than 0? Less than 0. Does this make sense from my drawing? Or less than 1, thank you. Less than 1, does it make sense that this less than 1 times a squared will make b squared smaller than a squared? Does that make sense? Yeah. So since b is less than a, this totally makes sense when e is less than 1. All right, so b squared is 4. A squared is 9. We should be able to figure out 4/9 equal to 1 minus e squared. I'm going to add the e squared over here, and I'm going to subtract the 4/9 here. Stop. Look up here. 1 minus 4/9. What's that going to be? Is that less than 1? Then we know we're all right. If we get something bigger than 1, we're in trouble. Okay. So e squared equals 5/9, or e is just plus or minus the square root of 5 over 3. Now, for eccentricity to work on a drawing, e has to be greater than 0. So just use e is the square root of 5 over 3. Did you do that? So now we know what e is. Square root of 5 over 3. We ignore the negative for a drawing. Now, once you know a, b, and e, everything's easy. Let's do the focal point, which is a, e, comma, 0, plus or minus. So a, e is just going to be 3 times square root of 5 over 3. Comma 0, which is plus or minus square root of 5, comma 0. Those will be the two. What's the square root of 5 close to? Is it bigger than 2? Less than 3? So does that make sense? Yeah, it does. Square root of 5 comma 0. This will be negative root of 5 comma 0. And then for the directrix, this is going to be x equal to plus or minus a over e. You know, in my head, e is less than 1, so that makes sense. So x is going to be equal to plus or minus a was 3 over root of 5 over 3. So I get 9 over the root of 5. Will be the directrix, and that should be a little bit bigger than 3. A over e, plus or minus a over e. And that's your ellipse. Try B. I won't do that on the video. 2 quick things that are new. Again, if you have b greater than a, you switch x squared over b squared plus y squared over a squared equal 1. And everything else is calculated the same, except notice that these are switched. And this x and y are switched. Everything else is the same. And then the focal points are on the y-axis, and the directrix are parallel lines. And then this focal distance property, so cool, it leads to this number 5 that I was telling you about. If you were to take a line f prime focal point to a point on the circle to another point focal point, the sum of the distance of those should be equal to the distance from to the vertices, which has another length 2a, and I'm just going to show those just real quick. We're going to see what the sum of pf plus pf prime is. It's quick. I'm going to just sink this down here, okay, and this I'm going to make my point P. So pf prime is going to be this distance a, this is going to be the a over e minus, we're going to call this x. Okay, and then if we're going to add this to, that was pf. Pf prime is going to be this distance a over e. It's going to be x minus a negative a over e. And each of these, P and pf is e times pn, so these will each be times e. Well, you can see that the ex's are going to cancel, and you'll get e a over e minus ex plus ex plus e a over e, and the ex's cancel out, the e's cancel out, and you'll get 2a. So the distance of the minor or major axes is the same as the distance from focal point to any point on there. In other words, you can draw this with string. Pf plus pf prime is 2a. And